Hello, everyone, and welcome to this EMQuest Users Group presentation. My name is Michael Fogel. I'm Director of Technology Development here at ETS-Lindgren, and it's my pleasure to take you through some tips and tricks on the EMQuest graphing capability. And hopefully by the end of this video, you'll have discovered some things you never knew but wish you did. And so with that, we'll jump right into it. The first thing I wanted to show is that I am running all of this on EMQuest version 1.14 build 10265. So anything after that is guaranteed to have everything that you're seeing. A lot of this has been around for quite some time, but there are a few new features, and I'll try to point out which ones are newer as we go along. And so the first thing I wanted to look at here is the options page and just point out these graph preference settings. So a lot of these things are actually settings that you can change in the graph control panel when you pull up a graph, but this lets you control some defaults so that if there's something that you can toggle, you can change so that a given default behavior occurs. And so as we add new things, a lot of times there will be a new default setting that will come in here that may default to being off simply because we keep the existing behavior, but you have the ability to come in here and turn it on. And so we'll come back and talk about a few of these as we go along. So with that, let's jump right in and let's just pull up a dipole pattern. And of course, one of the first things that you usually do when you get a big data set like this one and it tells you, hey, you got a lot of points, do you really want to fill the table, is a lot of times people just say no and go on. And that means I have no table data without reloading it or refreshing it some way. And we'll talk a little bit about that as we go along because you'll see some neat tricks related there. But to start with, let's just look at the graph. And of course, I've got mine set up to be the default comes up as tabs, but a lot of people prefer the pane view. And in the pane view, I end up with I've set this up so that it's actually calculating and transposing all of the antenna attributes. So I can come in here and view the gain curve, for example, as a function of frequency. And the one thing that you may not have seen or realize is some of the abilities here. So you have this reduced data set, and I could come in here and I could just reduce the data set and say, all I want to look at is the gain curve. So if I drag across here until I find gain, there's gain, and great, I've got the gain as a function of frequency. What you might not have realized is if you hover on the corner, and anytime I've got a multi-dimensional data set that has been reduced so that I'm not looking at all of the data, there's this little flyout. And so if I just hover in the upper corner of a graph, if that little arrow pops up, that gives me the flyout that lets me go, and now I can drag through as a function of frequency. Of course, that graph doesn't change much. This one here, we can tell there's a little bit of variation. And so that flyout is actually very useful. So in this case, I can drag through gain or any of the other quantities that happen to be in this data set. So we'll drop back to gain because we'll want to use that again here in just a minute. Now, the other thing to realize is that there are times when it would be really nice if, so let's say I come in here and I drag this graph. What I would like to do is be able to make them all move together, but I also don't want this graph to do anything because it's not related. Now, we've always had this functionality of linking graphs, but we've actually changed this behavior slightly from what you're used to. Traditionally, if I pressed link graph and then I came in and dragged this, all of the other graphs would immediately change to the format of this graph and try to drag, which means that the graph here with my gain value would not be doing what I wanted it to do. Likewise, if I was on the gain graph and I hit that, everything else would have changed to being a Cartesian graph. Well, you'll notice this time when I hit that, that did not happen because what's happened is you'll notice the icon is down when I'm on this graph, but it's up when I'm on that. So by default, only the graph that I've told to link actually goes into the link settings. So now these two are linked together, and as I drag them, they're linked, and I can come and click on this one, and I can link it. And so that gives me more control. Instead of the default being that everything gets linked and all you could do is unlink, now if I just click the link tab, it just toggles on and off, right? So this one's now unlinked. These two remain linked. And so that's a very useful feature. Now you'll notice I've got these little icons here in the video showing Shift, Control, and Alt, and that's because I've got some things. There are a lot of things that modifier keys change the behavior, and so this is something now that if I hold down the Shift key, you'll notice that it changes from the normal icon that's just indicating whether it's linked or unlinked to a link icon, and I'll click on this one and hit it. And what that's going to do is toggle between linking or unlinking everything. And now you'll see it's got an unlink. And so when I hold Shift and I unlink everything. If I hold Shift and hit link, now everything is been linked together. So it's a little more useful, a little better in that respect. And of course, like I say, when I change formats, it's everything that you've put together here is how the link behavior works. Now, link is nice, and it's certainly useful for things like the 3D graph if you want to see those things move together. But there are other things that I might want to do that would make life a little simpler. So let's just load the pattern again, and we'll come back in here, and again, I will go back to panes and tabs. Now, this is one of those preferences we talked about. So if I come into options, I have a couple of preferences in here, which is multi-graph displays as panes and multi-graph displays as tabs. This information actually gets stored in the data file as part of the preference when you save it, but there's a second thing that controls whether or not my preference overrides what's in the data file or the data file overrides the preference. And so that's this second setting. And so by default, even if I were to change it, save the file, and reload it, it would come back in based on my preference, not based on what I saved. So there's a couple of options there. But let's do something here where, let's say that I wanted to change a little bit of the formatting and apply that same formatting to a different graph. And so, for example, I'm just going to come in for now and say gain of antenna. Okay, so I've changed that label. Now, if I linked, then that would be forced onto everything, but I don't really want to do that. But what I can do is I can come in here and I can copy. So I'm holding down Control and C, so traditional Control C. Now, first off, a lot of people, I'm used to seeing screenshots taken of graphs in EMQuest where somebody's used the clipping tool or something else, and they've just come in here and they've snipped a section, and you get this whole thing, right? You get something that looks like that. And it's very obvious, well, I just did a clip. That's not necessary. It turns out that EMQuest has a copy function, right? So if I just hit Control-C in a graph, and then I go into something like Word, and I paste, I'm pasting that graph in. And the other interesting thing is I'm actually pasting it in by default. It's copied into the clipboard as both a Windows Meta file format and a bitmap format. So by default, it's coming in as a Windows Meta file. And we'll talk about the importance of that in just a second. But I can also do a paste special, and I could say, okay, paste it as a bitmap. And there I get, you can actually tell the difference because the bitmap is exactly what would have been on the screen. It's got the gray value. The difference here is that if I were to take and start scaling this up, what happens with the bitmap, of course, is you can see that you start seeing the grain of the bitmap. The nice thing about a meta file is that it's all line art. It's fonts and everything embedded, and so the actual drawing is embedded. So I can scale this thing up as much as I want, and it will remain line art and not get blocky like the bitmap does. So the bitmap is going to be constrained to whatever the resolution of the image was on your screen when you took the copy, while the Windows meta file is scalable. Likewise, if I went into a drawing package, Adobe Illustrate or CorelDRAW here, and I paste that in, I get that line art image pasted in, and you'll notice here that this is a group of objects. So this is a group of all the little pieces that make up this drawing. And so I could come in and ungroup the object and just take that graph, actually get rid of the background, and I could take just this graph, group it back together if I wanted to or whatever, and so I could drop that into something. Again, it's completely scalable, no loss of information or resolution when you're dealing with the meta files. So that's something that, again, very common behavior. It's been there forever, but it's possible you didn't know about it. Now, back to the graph settings. Let's say that I made labeling changes or other changes, or maybe I oriented things and I want my other graphs to get that information on them. If I copy it, I'm copying, of course, to the clipboard that I can use externally, but internal to EMQuest, it's copying the graph settings. So I can click on another graph and apply those graph settings by just doing a Control-V, by pasting onto the graph. And so that's a very useful tool without having to link the graphs. If I want a certain view of things, I can get that view by simply dragging that as needed. Now, moving on, let's say that I want to look at a particular orientation of my graph. I want this graph to be like this. I want this graph to be here. And I want this one to be, say, here. And over here, let's go back and set this up because we reloaded. So we just want to look at the gain curve. And in addition to that, let's actually call this gain curve. And make sure that this says gain DDI. Okay, so I've set the graph up the way I want it, and I can save this file, reload it, and all these settings go into the data file. But let's say that I want my next test, I'd like it to come up looking like this. Well, there's a very simple option here, which is Tools Extract Parameters. And you'll notice that there is actually a second setting there. I've got to go back to the pattern here. There's an extract parameters without graph settings, so that will remove it, and that's simply because there are times when I just want the parameter set. I don't want to carry all this. I want to see it just come up as default. And you'll also notice here that there's this clear graph settings, which if I have a parameter file that has embedded graph settings, then that will be available. If I do that, now that's been cleared out, and you'll notice I have clear graph settings there. So I don't want that. I want to go back and get the settings that I just had. So I'm going to extract parameters. And now we're going to run this virtual test. It's actually pretty fast. And of course it comes back to my default settings because I told it I want tabs, not panes. I'd have to change that in the option to get it to come back the other way. But you'll notice, of course, this is the exact same data because I extracted the parameters. I could have changed something about my device, but everything comes in the exact same format. So that's actually a very useful feature to be able to come in and extract the settings and get your graphs to come back looking exactly the way you want them. So next, let's talk a little bit about 3D plots in general and some of the features that we've got there. Again, most of these things are very old, have been there all along, but they're pretty neat little tricks that you can do. So the first thing, and again, this is something that you just might not have realized is there because it requires holding down a modifier key, either Shift, Control, Alt, or some combination. But there are various settings here. You know, the azimuth, elevation, and roll come about just by dragging, and those are the rotation matrices that rotate to get the orientation that you're in. So you can always come in here and change these values to be whatever you want and hit OK, and it will go back to those positions. But there's also a couple of things that you probably never really mess with, magnification and aspect ratio, that are useful as well. And those, the aspect ratio probably don't have a lot of use for, but you can actually get to that by holding the Shift key. And what the aspect ratio is that it is kind of the divisor, how much of a depth of field you have, right? So it's the perspective view. And if you pull it out far enough, you end up with no perspective at all, the fact that it just front and back look the same, versus you can push it in until it's pretty distorted, which is probably not what you want either. So the default aspect ratio is a 5, and so we'll put it back there. But that's all happening when I hold Shift and I drag. The more useful thing is, for example, let's say I turn this thing this way, and I wanted to make it a little bigger. Well, if I hold Control and drag, that's actually a zoom on the plot. So that would let me take and change the size of the plot in the window, and depending on the aspect ratio of the window, how I've got things set up, I can actually adjust these plots around to look exactly like I want them. And then, of course, I can still copy and paste and put that in an external document or whatever. Now, there are a couple of other things in here, and so let's come back in, and for the moment, we'll use this visualization. So we have these little icons. And, you know, they're very simplistic, although people have used the custom to add their own icon. And what we also have is the ability to come in and scale that. So if I were to hold Alt and drag, I can change the size of the icon. Well, that's not very useful. But if I hold down Control and Alt together, I can actually move this graph around. And if I hold Shift and Alt together, I can move the icon around. And then, of course, with all the other combinations, okay, I can zoom out a little bit on the graph. And maybe I want to zoom out there. But now I could, instead of having it up in the corner, which is the default that we set up, you can put it however you would like, right? If you wanted to move this thing down so that my graph was over here and this is over here, it's just a combination of using the Control Alt and Shift Alt and being able to drag those things around. So again, you know, just kind of neat, but you might not have ever realized that those things were there because they're hidden underneath the controls and shifts. Now again, some of these you can see they are actually replicated here, right? So when I did that, I moved the X and Y position of this. I also have the X and Y position here. So you have a way to manually do this in the control as well as controlling the size, but it's just that you have a user interface way to do it visually and play with the way you like. You also have things that will force given orientations. A couple of other things is the grid size on a graph. You may not have realized that you have the ability to change that grid size. You can even come in and change the line type. So if I go to a fine grid and I completely remove the wireframe, now you get the picture that you see a lot of times using a 3D card graphics, where it's just the shaded image with no lines. So you can also come in and go to a wireframe view, for example. Okay, so there's a lot of capability there just with the graph visualization. Now let's kind of start from scratch again and talk a little more. So we talked about the link and unlink and the copy and paste, but there's another feature related to the copy and paste, which is drag and drop capability. And again, we'll go back to our view here. Most of you are probably familiar with this, but basically if I have a graph, and let's use these two graphs, the theta and the total, or better yet, let's get a completely different pattern. So let's come in and get these two. So here now I've got a pattern that, if I look at the total, basically the dipole's just been rotated 45 degrees. So that way we've got something clearly that I can differentiate. And so if I come in and I look at the total on this graph and the total on this graph, let's assume that these are supposed to be oriented the same, but they're two slightly different devices, or I've made some modification. And I'd like to be able to compare them in 3D. Well, I don't really have the way to link them together because they're on different data sets. But what I can do is I can come in here and I can grab this, and I need to be in a mode that I can drag. So I need the pointer mode. And you can either be in the pointer or you can turn the pointer off and just have the normal arrow. But as long as you're at the arrow, you'll notice when I hold the mouse down and start dragging, I get this little do not enter type thing saying I can't drop it there. But the instant I come over onto this other graph, it shows up as that I'm carrying this document. So I can actually drop that graph on another graph. And what happens is that we now get this data set icon popping in here. And so what I can do is I can, in this case with the 3D graph, I can come in here and manipulate it to some orientation. Then I can do what is typically called a blink test, right? I can blink back and forth between these two data sets and see how different they are. Of course, if I wanted to, I could reduce the data set and come in here and say, okay, take the data set and let us show everything on a polar plot, and you can see all the graphs together. And of course, I can do a little bit of rearranging here. So let's go the other way. Let's take it down so that all we have is a function of phi angle. And, well, that's not very useful. So I come in and I pull the data set down and I say, yeah, get rid of frequency and theta. And what I want to do is I want to see as a function of phi angle, what do these look like? And so now if I come down and say at 90 degrees in theta, here's the difference between the two patterns, right? And you can, of course, scroll through frequency and everything using this little flyout, which is this little icon at the top. And so that's actually a pretty useful feature, pretty common. And you can even do a trick. So let's say that what I wanted to do was get these things on the same graph so I could use the linked graph. There is a little trick. Let's pull in this again. And so let's say that what I wanted to do was to compare this graph with this graph, but have them linked together. I would have to have these in the same data set. But I can do that by playing a little trick, and there's different orders you can do it, but what I'm going to do is I'm going to drag this data set up here. So now it's the second data set there, and then I'm going to drag this data set onto this. So that the first data set is still what it is, but if I link these two graphs together now, So I want to link this one and this one. And I want to come in and I want to look at the second data set in both of them. Now what I've managed to do is I've managed to make it so that that second data set are the two different graphs that I want to compare, and I can now drag them around side by side. So this is all kind of a background thing. It's just tricks that you can play because of the capabilities that you have. Now the thing to remember about every bit of this is that this functionality is solely in the graph, which means that if I save this file, all the data that's been dropped in these graphs goes away. The graph settings would go into the file, but the data itself is gone. So that's the limit of the usefulness of this. So let's look at something that gives us a little more power there. But before I do that, I have one other thing I need to illustrate. One of the common things that users like to do, especially when they first get their system and calibrate it, is to go in and take their reference dipole that the system was just calibrated with and run the pattern test on it, and then see if the gain that EMQuest gives matches the dipole. And so I could come in here and take this data set and reduce it down by one and get the gain curve. Right there. And of course I can put them side by side and kind of judge, but what I really want to do is I want to use the drag capability and drag this over. And so I'd go and I drag it on, and that's not what I wanted. Now in this case, I could actually come in here and just turn off all the traces. So I could hide all and then just turn on trace one and come in and find the trace for gain. And so that gets me there. Of course, I also need to come in here, turn on the auto scale to visible traces. And okay, that got me there, right? So I've got a gain curve and I can compare. So that worked there. But let's see what happens when I come in and I want to do the same thing, and I'll start with another copy of the gain response file. But now what I want to do is, the one thing to remember about EMQuest and the gain it reports, it's peak gain. So on a dipole, the peak gain may be at theta equals 90 degrees or it might not. In this particular data set it is, but there's still, this simulated pattern has some variation as a function of angle. So if I went in and looked at just the theta polarization here, because remember that's also total, not just the theta. But I could come in here and say, well, let's transpose this to frequency. And we're going to reduce by one, and we want to see the theta equals 90 degrees. Okay, so these are now the curves that I want to compare. And I'm going to go ahead and come in here and take this trace and make it nice and wide so that it's visible. And let us just drag this onto there. Well, that's definitely not what I wanted. EMQuest can't even interpret these two data sets being the same, and so it's having all sorts of weird behavior. So this is about as weird as it can get, because it's trying to transpose and do other things that it just can't do. Because it just drug the entire data set over and dumped it on here and then plotted it. And you'll notice it's not even plotting frequency against frequency. This is angular dependence here, which is why it's 0 to 360 degrees being plotted against frequency up to 2 gigahertz. So that is not what I wanted. So since that's not what we wanted, let's see if we can get there. So let's come back in, just load that gain file again. And now we're going to do the exact same thing. We're going to come in here and drag this graph on. But while I'm dragging, I'm going to hold down Shift. So this is a new modifier. It's been there for probably the past year now. But if I hold down Shift while I drag and then drop, what happens is that I've dragged just the visible data set. So it's only what you see in the graph is what you get. So if you drag and drop holding Shift, you're only going to drag the visible data in that format. It still creates the two data sets, but now I can come in here, and if I want to make this big so that you can see it clearly, there's the reference trace in the first data set, and you can see all that other data dragged on top of it, and you have much more control over what you've done. And if I wanted to even come in here and reduce this down further so that I only had a single curve, and again pulling in our response file, if I were to drag this and hold, now I just get those two curves. So that is a much more powerful method, and of course the same thing occurs here. If I drag this and hold the Shift, I only get that one curve. So rather than having to do what I did up here where I came in and turned off all the unwanted traces, there are only these three traces because that's what I dragged onto the graph. And so that's a very powerful tool. But we've taken it even a little further. And as you'll recall, we already talked about the fact of I hit cancel here, so I can't actually see the table. But you know what I'd really like to do is I'd like to be able to see the table of this data, or maybe just the total data. So I could drag, instead of dragging this graph onto another graph, you'll notice if I drag it to the desktop, it still shows a drop icon. So this is a very new feature, but I can actually drag any graph to the desktop, and I get just that graph and just that graph's data. And so now I have the list of that graph, and so this is all the data going into the graph that makes it up if I just drag without any modifiers. But I still have the ability to do the exact same modifiers. I have the ability to hold control and drag and just get the graph that I'm looking at. So when I came back to the theta graph here, first off, if I drag this to the desktop, I get a graph that has all of the frequency information. And it's at the top. You'll notice it doesn't match this formatting. But there's another trick, is that if I hold control and drag, the display changes because it actually changed and copied over matching the format that I had it oriented. So now I actually have the frequency data, and of course if I hold Shift and drag, I get just the graph as it looks, and there I don't have that extra term. So here I could still transpose, right? I could still come back into this data set and I could transpose it back some other way and see it as a normal graph. Here, I've actually lost that ability. If I come in, the only transpose I can do in the graph is I could change frequency and phi angle, and so I get all the phi angle graphs. But this is very powerful now because I have this graph and I can actually see the data. And the other neat thing is I can come back over to this where I've combined this. You'll notice when I look at the table, because I just dropped it onto the gain file, again, it's temporary in the graph. So the gain file won't save this. But if I take this graph and I drag it onto the desktop, now I have those three data sets side by side, and I can actually see the numbers that are in EMQuest, and I could take and come in here and do export to Excel or CSV. So we'll just use that and bring it up in Excel, and there you are. So if you wanted to do some math manipulation in Excel, you can do that. The other thing, of course, is I can actually come in here and do a save as and save this as a dropped graph file, whatever I wanted to call it. I probably should have called it gain something or other. And I can save that to a file, and now I've got that and can always pull it back up. And so this is actually a very powerful tool. Just with simple drag and drop, you can manipulate your data in all sorts of ways that you might not have thought of before and merge it together. And it's all getting merged under the data set header. But if I wanted to change that, I still have things like the tabular graphing tool, right? So I could come in here and take this data set. I'll just take part of it, and I can come in, and then I can come in and view the graph, and I can make whatever changes I want here. And of course, this is a graph. I can drag this off onto the desktop and keep doing this over and over. So I have a lot of power to manipulate the way things are organized just by dragging onto the desktop and combining graphs and dragging those and transposing and whatever else I might want to do. So very powerful new feature to EMQuest. And so to finish off, I wanted to show you something that will be most interesting if you're doing intended design work where you're doing vector pattern measurements or just any pattern measurement that takes a lot of data. So let's close all of these, and I'm going to come up and pull up a high-resolution vector pattern test. This will still go very rapidly because it's all virtual, but I wanted to let you see a change. So those of you who have run a vector test in EMQuest have been very familiar with the fact that it always shows you real and imaginary part. It's showing just the raw data, and it's not until you get to the end of the test that it post-processes. And part of the reason for that was to minimize overhead on the test, so that we're not taking away from test time to convert things over into nice, pretty units. Not that on today's computers that should be a big problem, but here we're throwing a tremendous amount of data, and now what you'll notice is that we're getting values in dB, and we're actually taking advantage of a feature that's been in the graph for a while but not exposed for most things, in the fact that we're actually plotting complex data. And so you can come in during the test and change what it is that you want to plot to be linear, log magnitude, whatever. Typically you would do log magnitude or phase. You could transpose. The other thing I want to show, and then I'll abort this before we continue, is you'll notice that the graph is actually slowing down quite a bit. But if you watch the test timer, it's not really changing and being impacted much. Traditionally, you would have needed to come in on a test that's got this much data. You would come in and go to options, and you would actually turn off the graphing. You'd turn this to a -1 so that the graph, it's not trying to take all of that data and graph it constantly. Well, now the graph capability, this has always been the intention, but there were certain reasons it just wasn't possible in the past. But the graph is no longer blocking. It does not prevent the test from continuing. The data is transferred to another thread, and it's only after the graph is done processing the data, converting it over into the format and plotting it, that it comes back and asks for another set of data. So as the data set gets very large, which this has become quite significant with the number of points that I have here as well as all the angles, the graph may slow down, but it doesn't slow down the test, at least not any significant amount. So with that, that's just a couple of new features that some of you may find useful. So we will abort this test, and thank you everyone for watching. Hopefully you found some useful information in this presentation on graphing. Have a nice day.